Put in some audio. Should be able to hear me now. Hey, everybody, welcome to. I hesitate to call this a Astro Coffee Hangout because it really isn't. We're going to change the branding here in just a little bit, but I didn't have anything handy. But today, what you're watching is something. Well, Brian and I will talk about it in just a minute. Anyway, today we're going to. This is something we're trying a little bit new here on my channel and also on Bryan Keating's channel. We should be streaming on all the channels. Just to let you guys know, I'm looking at Twitch, my YouTube channel, Twitter, and Periscope. I'm sorry, Twitter and Facebook. So if you comment on any of those, I can see them. Let me bring up Dr. Bryan Keating with me now. Hey, Brian, how are you?
I'm great, Tony. I'm really looking forward to this new project that we're hopefully going to keep going for a while.
Yeah, let's talk about it a little bit. So we're going to just spend maybe 2 or 3 minutes on it, then we're going to dive into our topic. But Brian and I were talking about ways in which we can collaborate more. And one of the ideas that we had is that Brian actually has access to he does some amazing interviews, and he's interested primarily in interviewing authors of books, but it's all on his channel. And so I wanted to give you guys a glimpse at what he's doing so that if you want to learn more and actually watch his full video or full interview, then you can go to his channel and watch it because we're going to kind of whet your appetite with the topics of various interviews that he's done here. And because they're book interviews, I want to rebrand this away from Astro Coffee. It's just the one thing I had that was the most close to what we're doing. And we're going to call, what were we going to call it, Brian? We were going to Astro.
Maybe like Book Scope or Book Observatory. Maybe we'll do a little poll. What do you guys think? Book Scope.
Give us some
Book Observatory.
In all the suggestions. Yeah, in all the chats. Let us know give us some ideas here, and we'll call it that, and we'll get a graphic made and all of that. The idea here is that on the Thursdays where I'm not doing any sponsored hangouts from the American Astronautical Society, that this Thursday is open, right? So we're going to go ahead and keep it going by doing stuff like this. So, and today we're going to be talking about do you want to give some background on maybe what you're doing over on your channel with this interview series and stuff like that? Then we'll talk about Stephen Wolfram.
So, as I've been on your show a few times now, and people that might remember, or maybe if you're new to the channel or new to me, I'm a professor. I teach physics and astronomy at the University of California, San Diego. And in the course of my career, I've always been fascinated by books. And in fact, I never thought I would write a book, but I ended up writing a book called Losing the Nobel Prize, which was published in 2018 about the experiences that I had as a young scientist, basically a mentor to a student, and then becoming a mentor myself and dealing with a lot of emotions and rides, ups and downs, and trying to uncover what happened at the beginning of time, if indeed there was a single beginning of time. And that story was cataloged there. And it was really came about because of the influence of just a few authors that had influenced me as a young child up until the time I wrote the book. And so I always wanted to do a book, but I never knew if I'd have the ability, the time, the resources to do it. And I ended up realizing that the story of the Bicep 2, acclaimed discovery of inflationary gravitational wave impact on the cosmic microwave background, provided such a venue for me to tell a story which had never been told before. And to make matters better, I was intimately involved in the project and in the aftermath of it, as well as with the selection of the winners of the Nobel Prize in 2016. And so I want to catalog that for kind of posterity and also use it as an opportunity for a legacy for my children, my biological children, and also my ideological children, the students that I've been blessed to have. So I wrote that book, and I don't know if I'll ever write another book, but the point was that I got to interact and get the feedback from so many great authors, ranging from Lord Martin Rees to Sir Roger Penrose, and many, many luminous authors around the world. And I couldn't be more happy to have remained friends with them. And what I'm trying to do in this era of COVID-19, I realized that many of these authors are putting out phenomenal books, but they're not getting the opportunity to go on a book tour. All book tours have been canceled as of early March. So I've gotten some phenomenal guests that, quite frankly, I probably couldn't have gotten weren't for the impact on book sales and book promotions. And my niche is in science nonfiction, and try to take advantage of that. I do some other things as well, but mostly related around either academic freedom or free speech kind of things, as well as mostly 90% of what I do are science books. So we started the podcast probably 2 years ago, and it's part of my role at UCSD's Arthur C. Clarke Center for Human Imagination. The podcast is called Into the Impossible, Tony. And the reason that it has that name, some of your listeners and our listeners might know, is that's the title of Sir Arthur C. Clarke's second law. Everybody knows his first law, which is any sufficiently advanced technology is indistinguishable from magic. The second law of Arthur C. Clarke, who is a science nonfiction writer and a science fiction writer. So he's kind of emblematic of what I like to do and what I'm interested in. His second law was to find out what's possible, you must go a little bit into the impossible.
Very nice.
And so that's what we're doing. So we're interviewing brilliant minds. So I've already had on some tremendous thinkers, including Stephen Wolfram. And you know what I found out today, Tony? This is one of my highlights as an academic. Stephen Wolfram follows 5 people on Twitter. Sorry, he doesn't. No. I'm sorry. He follows one person on Twitter, and you're looking at him.
Oh,
he follows
wow.
4 companies, and he follows one person. And for some reason, I tweeted out today that he is following me, and it's kind of cute to be in that position there.
Awesome, Stephen Wolfram. That's great. Okay.
Yeah.
All right.
And we're going to be talking about it. Yep.
Exactly. So most of you are chatting. I just want to acknowledge some of the chats here. You guys are suggesting topics like gravitational waves and things like that. We can absolutely do those things, but we're going to, and we'll use your ideas as feedback for future shows like this. I think. Just so everybody's clear, I think that you're going to be on for about a half an hour, and then you're going to go, right? Because okay,
right. I've got homeschooling for my kids and for my graduate students as well. So, but we can go a little bit longer, maybe until 20 to the next hour.
Okay, I just want to I want to give you, if you're on a time crunch, then I want to make sure that you are I respect your time in that way. All right, well, so there is apparently today's topic is about one of the interviews that you had recently done with Stephen Wolfram, and apparently I don't know anything about this, but apparently there is a controversy surrounding what he's doing. So you want to set the stage, and then I will play your video clip.
Yeah. So many of your listeners might know that the so-called holy grail in physics is to come up with what's known as a theory of everything, a theory that would unite the 4 fundamental forces of nature, which are electromagnetism, the 2 types of nuclear forces called the strong and the weak force, and then the force of gravity. And to date, we've had inklings of how the first 3 of those can be unified, the so-called electroweak theory, quantum chromodynamics in the case of the nuclear reactions. But we haven't been able to unify those 3 very high energy forces with the weakest force of all, which is gravity, which is kind of unusual, right? Because we think of gravity as pretty strong, especially if you try to go to the gym and lift some weights. But it's actually the weakest force, which gives it some benefit in that it can pervade the entire universe, unlike, say, the nuclear force, which can't escape the confines of the nucleons, which is about 10 to the 28th meters range, versus the force of gravity can act over 10 to the 28th positive meters in range. So what's so fascinating and has vexed physicists since the time of Einstein, really, this is Einstein's unfinished symphony in some sense. He wanted to unify all 4 laws of nature into one, in particular to understand how quantum mechanics, the theory of the very small, the subatomic, the microscopic, could be combined mathematically. When I say a theory of everything, I mean that the math is described in perhaps a single equation, and that single equation encodes the properties of how gravity performs on quantum mechanical scales, so fractions of the size of a nanometer, perhaps. So what Einstein tried to do was ultimately unsuccessful. And what I see Stephen Wolfram doing, along with other people that I'm hoping to have on my show next week, Eric Weinstein, who's a renowned intellect. He's the managing director of Peter Thiel's Thiel Capital Group. Of course, Peter Thiel, the first investor in Facebook. founder of PayPal and many other companies. Eric Weinstein is a physicist, mathematical physicist with a degree from Harvard, and he's come up with a new theory called geometric unity, which shares in common one crucial fact with that of Stephen Wolfram's so-called physics project. They're both trying to come up with a law that unifies all the laws of physics under one rubric, under one umbrella. And you can wonder, well, how could there be two theories? I mean, shouldn't there be the theory of everything? And that's probably true. But in the context of both of these gentlemen, their particular theories have been absolutely shredded and assailed on the internet by pundits, by eminent physicists. And the reaction to it has said a lot to me about the sociology of science and how people can confront these biggest topics possible and yet be sort of almost to the level of ad hominem attacks on ideas of very well-meaning people, and the reasons why maybe we can get into. But it's been a study in sociology to both these two gentlemen putting out theories of physics that purport to answer the deepest question in nature.
Okay, well, hang on though. Isn't it? I mean, I've got a lot to say about this idea of a theory of everything that could be printed on a T-shirt. I just don't think nature is ever going to come down to that. But this idea that their ideas are being, you said shredded was your term. I mean, come on, that's science, right? If that's how science works. If you've got an idea, it needs to stand up to rigorous examination. So, I mean, okay, the ad hominem attacks. That's a slightly that's sort of a sign of the time we live in, I think. But the isn't that healthy to have somebody really just like run your ideas through the grinder? Certainly that happened in the early 20th century. I mean, Einstein hated quantum mechanics, didn't he? So
and some of the things that he would say, really he didn't hide his disgust for it. But in the case of this of these two new theories that are being put forth, and maybe today we'll just focus on Stephen Wolfram, there's been criticism that he's putting this out really, as a way to grandstand in the words of one physicist, and as a way to circumvent the ordinary rules by which physics is supposed to be managed and presented, namely by presenting it online and not in a refereed paper in a prestigious journal.
Oh, is that the controversy? Is that really the problem?
But it's twofold, Tony. It's very interesting because one part of it is that. One part of it is, it must not be right because it's in this journal and it's not hasn't been submitted or even or accepted.
I see.
So that to me is disappointing because I can give you someday we should sit down and talk about how many great discoveries printed in the most prestigious journal called Nature or Science have been later retracted and withdrawn, even though they went to referee.
To have that conversation. That needs to happen for sure.
Even to the point that there are press conferences held at the White House, held at NASA, for results that later had to be retracted. And I think that's it's kind of a precursor to actually giving it some deep thought, saying, it was only published online, I'm not going to pay attention to it. Now, on the other hand, there have been attacks on it that it's not mathematically rigorous. And I think those are valid, but it's not valid in my opinion, especially in the case of Stephen, because what Stephen has done is he's made it completely public. So he's listed all the code, and we'll get into the details of it. And his philosophy in general, he laid it out. As I said in my podcast for the Arthur C. Clarke Center called Into the Impossible, which we'll put a link to, or it's on my YouTube channel. It's the best place to look. So I should say on my YouTube channel, when I do an interview with an author, like what I did with Stephen and did with Peter Diamandis, what we'll talk about maybe next week, or Sarah Scholes, we'll talk about the week after. These interviews are put online on iTunes and the podcast, your favorite podcast store, but they're also put on YouTube. And the YouTube has some bonus features in that you can see videos, B-roll footage, links to pictures, other videos. It's much more interactive. And we include show notes with many of the episodes as well. So we want people to really dig into it. So I've given exercises for the reader to kind of the listener, the viewer, whatever, to go through in that podcast. So please tune into the YouTube channel.
Thanks, Bryan. No, really.
Yeah, exactly. Right. You don't have enough going on.
Well, do you want me to show your clip?
Yeah, let's do it.
Let me do it.
The only thing we can be sure of about the future is that it will be absolutely fantastic. 5, 4, 3, 2, 1.
today I contacted you because I, like so many of my colleagues, are so excited about this new physics project that Wolfram is involved with and that you pioneered. I want to understand how it came to be, how you were inspired by young people in your life, because we have a mission here to inspire the imagination of young and old. And this particular was kicked off by young people, and how it's made its way into the world. But that connection to technology sort of intrigued me when I had that realization that you had completed more calculations by orders of magnitude than any other device invented before the computer, let's say. It made me think, like, what would have happened, had you been born a century earlier? For example, we're born into technology that we have, and there are certain bounds on what technology you can create. And you've proposed this new physics project, but would that have been possible 30 years earlier or 50 years earlier? What do you feel about that?
Yeah, I think the answer is basically no, for two reasons. First reason is a really practical one, which is, part of how we know what's true is by doing experiments. We can now do computational experiments. That's a fairly new thing. If we'd been a lot smarter than we are, we might have been able to figure out what was true without doing the experiments, but I don't think that's feasible. So the first thing is the practicality of being able to do computer experiments. The second thing is the way of thinking about things that computation has brought to us is something that comes about because we're just used to computation all around us. And that's a sort of paradigmatic advance that I just think is not achievable without sort of a lot of exposure to computation in the wild, so to speak.
All right, dude, you spent some time on that, didn't you, with some editing skills there?
Yeah, I have a very good editor at UCSD I'm working with on many projects, and he's a member of the Producers Guild of America.
All right, well, there's your taste, guys, of the interview. The way you listen to it, you could either get it on iTunes or go to his channel and get the extras as well. One thing I've learned about doing this, Bryan, and one of the reasons I'm here, and thanks in large part to, let me give a shout out to James Dugan, who's from Australia. He's here. He is like begging me to, continue to make content on YouTube because people don't like to switch platforms all that much. And so, James is one of the best, viewers I've had for a long time, and I really care about what he thinks. And so I want to make content that he can enjoy and get at the platforms that he accesses. And so what you're doing here is really a good thing because you want to be on the platforms where these people are. And a lot of people, hopefully my audience, you guys will go and check out some of these things. So what was the thing about that interview? Just give us a little, insight into about what he's like, and some of the things maybe that one or two things you learned from the interview.
Well, I started talking to him and his publicist, or assistant rather, and she had said, well, the interview, how long is it? And I said, well, it could be, as short as half an hour or something like that, or it could be as long as he wants. And she said, well, he only talks, beyond 30 minutes or so if he has respect for the person he's talking to. So I said, all right, so it's going to be a short interview.
Yeah.
Because
so there's a threshold there.
Exactly. But we ended up speaking, as you can see, for 2.5 hours, and I debated whether I should break it into 2 videos or into one. I just left it as one. He's such a brilliant intellect that I felt that even though people were criticizing him online, some of my best friends, most renowned members in the scientific academies, they were saying, they basically don't buy it. It's not worth, looking into because nothing really fruitful had come out of his previous book, which was our previous extensive book on physics, where he made a big claim about science, and that was called A New Kind of Science. And they were saying, they were dismissive. And so I was a little bit hesitant to just do kind of a fawning, gushingly positive interview of him, because I know that there's a lot of skepticism about both the veracity of what he's done, the claims that he's making, how bold, audacious they are, that he's really unified or has a path to the unification of physics. Look, Tony, one of the things that comes out of his physics project is essentially the speed of light, which before, it comes out of Maxwell's equations, but it's not a prediction of Maxwell's equations. We have to go out and measure things, indices of refraction, speed of propagation, and then now it's a defined quantity. But in his new physics project, it actually emerges from the properties of space and time themselves. So that's pretty intimidating. That's pretty audacious And I want it to be fair to both sides. I want to give him a chance because he's such a brilliant. I mean, no one could deny this guy got his PhD at age 20 from Caltech, a small technical college. You may have heard of it. Yeah. So, and he was the youngest MacArthur Genius Grant winner. So this guy does, and he's founded multiple companies. His flagship product is in your pocket right now. It's called Wolfram Alpha, and it runs on the device that is spelled SIRI, and many other things. I don't want to set off too many smartphones, etc. But the bottom line is, this guy's had a huge impact. Oh, and by the way, he worked on a small movie called Arrival. Now, all that being said, that doesn't give him a pass. He still has to pass through the rigors of being confronted with the acceptance and veracity of his claims. And so I got into that with him. And I wanted to go into it with him because he's at heart a mathematician, a philosopher, a logician. And I said, look, one of the things that I want to talk to you about is the so-called falsifiability of your theory. Is it possible to prove your theory not right, but to prove it wrong, in fact? Will it be possible for it to merely evade all possible tests and therefore escape, kind of by the judiciousness of a lax jury or lack thereof? Or does it actually make a bold prediction that we'll see, certain properties of black holes when they coalesce? They should manifest certain properties in their waveforms, in their signals. And he discussed that with me. And that was the first time I think he had really discussed that.
Let me get to Uncle Bill's question, because it's what I'm thinking the same thing of, and so I may as well just he's putting it a little bit better than I would. He's asking, doesn't it matter that he is inviting peer review? I mean, why is it wrong that he's self-published and the peer review must happen publicly after the fact? Why is that wrong? I mean, why are people getting so bent out of shape that he publishes it first and invites peer review later?
Well, I think I want to be fair to both sides. So there is this notion that peer review is the hallmark of science. I want to point out, as I think he might have in this journal, that how old do you think peer review is?
How old do I think it is? I think it's probably something started in the 19th century, somewhere in there, maybe sometime. Definitely after Newton. So,
that's right. Certainly after Newton, Galileo, and many people before them published themselves. They would publish pamphlets.
That's right.
Galileo
Darwin wasn't peer reviewed. I mean, the origin of species. So.
That's right. And in fact, we spoke a lot. Stephen and I spoke a lot about Darwin and the influence on it. And there is a certain, he has a very healthy sense of the stakes that are at play, and even of his own abilities. And I like to say, he's earned a lot. He's earned as much as a listening to. There are some of my colleagues who say he's grandstanding. He's not actually doing anything. And I point out, one of the things that this comes to in the end is that it's sort of a network theory. It's sort of a networked, the way that space and time are integrated to one another is sort of based on these very simple rules of propagation in these abstract spaces related to things called Hilbert spaces. I don't want to get into it, but he describes in detail in the paper. There's a 459-page paper that he put on the archive, which I have a link to in the show notes. And so it's not that he's hiding anything. The other thing is that he's made code available to do these things. Now, my main question to him, Tony, in all honesty, is this just a semantic question? In other words, if you say that, I was explaining to one of my kids the other day, I said, look at that tree. You see how like the branch, forks out into two pieces, and then those fork out into two pieces. That's called a fractal. The self-similar patterns that are exhibited throughout many different realms of nature. And a lot of the patterns that he generates in the physics project look a lot like fractals. They have certain properties similar to the so-called game of life, not the board game, but the late John Conway now. And the question is it semantics? Are you just saying that like things in nature are fractals? Or are you saying, and therefore, there's rich structure, self-similarity, fractional dimensions? Or are you saying something that there's actually source code for the universe that's running on some operating system? And does that require consciousness? So that's what we got into. And that's what I kind of pressed him on. And I thought his answers are very interesting. He's a student of history, and you must listen to him. You don't have to agree with him, but you're going to have a hard time really kind of pointing out where the logical flaws are. You might not agree with his presentation, on the other hand.
Right. And Well, that's definitely an invitation to listen to the full interview then, because I would love to hear what he has to say on that. So,
Yeah.
okay. Well, let me get to a couple comments here. Cosmos Safari on Twitch is commenting, the current scientific community continues to be that of privilege and fame. He also has a question. Do we know the potential technological implications that could result if we had a theory of everything? What technological links would there be?
So it's very interesting. When you talk about theories of everything, they can classify into two different camps, essentially. There's sort of the camp that Stephen is in, where he's looking at the fundamental rules in sort of a computational perspective. In other words, there's sort of the theory of everything would be a rule, and he's not actually claiming a theory of everything. He's claiming that a fundamental theory of physics at its heart is operating according to simple rules. Those simple rules will exhibit patterns, and we can compare those patterns to various structures that we see in the universe. Therefore, just as your computer can't make a pattern that its coding or its hardware is incompatible with, almost by definition, that you'll sort of learn the source code of the universe. So he thinks of everything through the lens of computation. I didn't appreciate that until I had this interview with him. On the other hand, someone like Einstein, or his pseudonym or similar name homonym Eric Weinstein, they have geometric theories, and the geometric properties of space and time are encoding boundary conditions on the behaviors of particles, of fields, of forces. The fact that space-time has a certain number of dimensions will mean, in that case, that you can only have certain types of motions, or you can only have certain types of particles. Those particles can only have certain types of properties. Their spin, their mass, their charge, those will behave in certain ways depending on the geometric structure in which they're inherited within. Now, those are very different things, right? You can imagine that you could take a Stephen Wolfram's program and think about a way to, operate an iPhone better, or solve a quantum computing problem better, or rule out certain theories of physics even. So he claims he can rule out something called the simulation hypothesis. Not going to get into that. It's fascinating. I want to talk to you about that some other time. That's basically that we're in the matrix right now.
Yeah,
on the
I would
other
love
hand,
to have that one.
Yeah, Weinstein is saying something completely different. It has no practical, it's like, how many practical innovations have come from the fact that there's 3 generations of leptons? None. I mean, have you I have a faster Google phone, so now I can because of these 3 generations of leptons? Nobody says that, but they are inherited from the fact that the space of mathematics, the geometric space, has certain properties. So if one of them's right, Stephen, then there could potentially be vast implications for practical benefits, for example.
Okay. All right. So I had a great question here, and it just scrolled past me. I know what I wanted to ask you. This is just for me. Why is this assumption, and it's starting to get on my nerves? Why Stephen's doing it? Certainly, most major minds in science do it. Why does the basic assumption the universe operates on a set of basic, simple principles? Why in the hell does it have to be simple? I've never understood that. Why does it have to be reduced? Why does the entire universe have to be reduced down to an equation that fits on a t-shirt? Please explain to me where that comes from, because it doesn't seem obvious to me that should be the case.
One of the people I most want to have on is sort of a critic of mine who was really harsh in her review of my book, but she's a brilliant scientist in Germany. Her name's Sabine Hassenfelder. I hope to get her on my podcast soon too. Yeah. She has a book that was a bestseller called Lost in Math. And her thesis is that physicists are drawn to the attractive or unattractive aspects of a theory's mathematics. In other words, a physical theory describes the properties of matter, of energy, of space-time itself. There's no reason, according to her, it should be beautiful. Now, when we say something should fit on a t-shirt...
I agree with that statement.
Okay, that's her statement. That's her statement. There are a lot of physicists that disagree
with her.
And so, yeah, okay, good. And I want to get her on my show so that you and I can talk about the interview that I do with her on my podcast. So hopefully she'll be kind to me.
Okay.
But the other camp says no. There have actually been great breakthroughs using pure mathematical concepts, such as the concept of symmetry, and even the concept that symmetry, when it's slightly broken. Have you ever seen these pictures? Maybe the folks out have seen this, where you take a human face like Brad Pitt, who's like the handsomest guy in the world next to Tony, right? Next to you, and they take his face, they divide his face in half. and then they reflect his face back on its other side. So in other words, his left and right side of his face are forced to be mirror symmetric. He looks completely disfigured. He looks, and you'd say like he's not the sexiest man alive. It's back to Tony. But in reality, that's because the human brain interprets certain things as beautiful. And those things that are beautiful are usually symmetric, but they can't be too symmetric. They can't be too perfect. And what she's saying is that these too perfect images that we're seeing from people are messages in physics are contaminating the way that physicists do things. So it really cleaves to whether or not you think physics is almost like an art form in that it inherits the symmetry, the beauty, the elegance, and compactification. You'd agree that 100 pages of equations is less elegant, perhaps less beautiful than a single line which could fit on a t-shirt. That doesn't mean it's right, but I'm just saying that's the drive that she claims has corrupted physics and held it back over the last 50 years. She basically claims there's been almost nothing in the last 45 years that's been a true breakthrough in theoretical physics.
And I can't wait to hear this interview because I like her already. That's exactly right. I wonder where the new innovation, where are our big contributions in physics? It hasn't really been anything other than a fleshing out of stuff that happened in the 20th century. So I think she's got a really good point there. So all right. Cosmos Safari is also. Oh wait, better and better. I want to get to his question. Where did it go? He was. No, darn it. I'm sorry. Okay, better and better is asking. Wouldn't any legit theory of everything have to have the speed of light emerge from it? If it's legitimate, the speed of light better be in there somewhere.
Yeah, that's certainly true. So the theory of everything is merely going to, not merely, I shouldn't say that. It's a tremendous accomplishment if it's ever achieved. It's going to combine the laws of electromagnetism where the speed of light is manifest. What's different about Wolfram's theory is that it is sort of really kind of looking to provide a reason for its particular value. Not that it can have an arbitrary value. In other words, there'll be some parameter which by virtue of the laws are encoded in the theory of everything tell you perhaps what the masses of every particle should be. Right now we measure those. Those are used as input to our theories, and we tune the theory, or we look at the data and we examine the likelihood of a theory given that data set, or sometimes the reverse. But anyway, the point is the parameters are usually taken as inputs that you must measure. But on the other hand, it would be nice to have a theory that predicts these are the values that you're going to see. Like a prime number hypothesis in mathematics could tell you what are the properties of the next prime after the biggest prime that you've ever discovered. So that's what it means to have something emerge from the physical theory itself. So we don't have a theory that tells us that without any parameters, without measuring the properties of the vacuum, or without measuring the speed of light itself with the various ways that we have of doing it.
Okay, we only got a couple more minutes, and I want to make sure I get some of these out. So Adam Synergy's commenting, Wolfram may be grandstanding, but at least his work isn't hidden from everyday people behind a paywall. Amen, brother. Amen, brother. I hear you. And Cosmos Safari, I feel like the best science is done in the open. Many of the ideas of 20-somethings are historically the best work done in the life of a scientist or an artist, etc. Many times, people waste a lifetime trying to gain consensus on their ideas enough to be published, and they tiptoe around their ideas to keep them from being blocked from publication. Interesting.
That's very interesting. That's a very good point. And it's impressive that the question is.
Well, Cosmos is a teacher, so I know him. So
okay. Yes. I was going to say, I mean, it really is digging into the sociology. So there's a notion in at least among physicists, that everything is applied physics. So except for math. So math is needed to provide the roots and the foundation of the tree in which grows physics, and then out of physics comes chemistry, biology comes from chemistry, et cetera. But way down in the branches, in terms of, or higher up towards the heavens, if you will, is like sociology and psychology. And I think this question that is being asked is relevant, because it's saying, what is the sort of reaction? Now, I disagree. I don't think that people do their best work in their 20s. I used to have this conversation with my father, who was a mathematician. And he said, people don't do their best work in their 20s. They do their best work over a 10-year period, which is usually, associated, correlated, if you will, but not caused by their age after they get out of their undergraduate or their PhD. But I've known people that have done phenomenal work as they got older. In fact, an experimental physicist or even a theoretical physicist never does their best work in their 20s. You'll be hard pressed to find somebody who does outside of an Einstein or somebody like that, because physics is about accumulating knowledge and wisdom about the events of the universe, and you simply don't have enough of a toolkit when you're 21 or 22. It's not impossible, but usually you need that acquired wisdom, which takes time. Whereas mathematics is a little bit of a different subject. But even there, I think if you got your PhD in math at age 30, you could still do great work up until your 40s and even your 50s and beyond.
Okay, well, I just want to be clear on one thing about peer review. I want to make sure that I am clear on the idea that I think peer review is vital, that it does not happen without, science, it depends on it, and it is not something I'm trying to downplay. It is a human endeavor, and without people checking your work for mistakes or making sure it's consistent with the body of knowledge that we've already gathered, all of that makes peer review quite important. But I do think that there's a lot of barriers to new ideas as a result of peer review process. So that's where I was coming.
Look, what is peer review? It's an adversarial process. And that means that you have to but it has to be with two people that have a common goal in mind. It can't be to take someone down. Like on Twitter, it could be, I want to flame somebody and insult somebody. But in a journal, it shouldn't be about that. You shouldn't have people ad hominem attacking. And sometimes, unfortunately, Tony, I've read terrible things, especially recently. Fellowships just got announced for certain very prestigious graduate fellowships. And I've heard like these poor students writing reports that like the referee said that they're not very good and their careers are, not likely to be very successful, and that they only got to a certain place because of a certain reason. It's very insulting, and it's because it's anonymous. So, you'll say something very different to me in person or when I'm looking at you than you will say to me on the internet or anonymously. And actually, one of your in the chat room, somebody just said, talking about the psychology of science. I can't read their name, but it says scientists are the same psychologically as other people and thus are limited and have herd mentality. I disagree with the latter part. It doesn't necessarily imply that we have herd mentality, but we are human despite the stereotypes. That's right. And because of that, we have biases, and we're just a normal person in that way. And sometimes we're biased against authorities and we're biased against novelty.
Good. Okay. Quick question from John Suffel. Some years ago, a mathematician was just to pass the time working on a 15-dimensional mathematics and found he'd unified relativity and quantum physics. Would this be valid in the real world?
I think that this is, he might be referring to Eric Weinstein, who is a mathematician.
Okay.
He did have this talk at Oxford in 2013, so that would comport with the statement about a few years ago. Eric does claim to have a higher dimensional representation that encodes the properties of gravity, the properties of quantum mechanics, the properties of dark matter, et cetera. And like I said, he's tentatively agreed to come on my podcast. And I do want to talk about these issues with him. And as I said, I don't give anybody a free pass, but I'm also not 60 Minutes. I'm not going to show, what did you do? Some people are saying, why didn't you ask Stephen Wolfram about his employees filing a lawsuit? I'm not 60 Minutes. Sorry, go to another channel.
This is an expose where I'm trying.
Yeah, exactly. You're right. Yeah. Are you going to stop beating your grad students?
Whoa. Yeah. Well, maybe ask about that. All right. So, anything else you want? I think we've done your time here. So, anything else you want to remind people of before you head out?
Yeah, I would really like to, leverage a lot of the synergy that your channel has with mine and your listeners and viewers. And I've recorded, 42 different episodes over the years. Some you'll like, some you'll love, some you'll hate. But the bottom line is I get some of the greatest intellects because of where I am at UCSD in the Arthur C. Clarke Center for Human Imagination, that I get the opportunity to talk with Nobel Prize winners, with Pulitzer Prize winners, with a live interview with an astronaut while she was in outer space. And I want to talk about that with you at some point too. How do we communicate STEM to the people? My mission, as I say in my book, is all about giving you guys out there a return on your investment. You guys pay my salary as a scientist. It's supported by the federal government. I feel, and I'm also a state employee of the state of California. I love to share the knowledge that I've gotten, and most of the knowledge I've ever gotten in my life came from books. I love books. I love ideas. And so give us a hint of what we should name this segment on Deep Astronomy. We'd love to have you listen. I'd love to have you watch the full videos on my YouTube channel, which is Dr. Bryan Keating, Dr. Bryan Keating. on YouTube if you can't figure it out. And then also go to the Into the Impossible podcast, leave a rating, review, and then you'll be entered. You can get entered into a competition to win Stephen's latest book. And we'll do that for the author, the listeners on the iTunes podcast.
All right, great. So what do we want to talk about next week? Just to give them a little, we talked about it briefly. What do you want to
I think we should, next week we should talk about Dr. Mario Livio. He has a new book coming out called Galileo and the Science Deniers. And Mario is a world famous author of the Golden Ratio and Why and Brilliant Blunders. He's a friend of mine, and I'm gonna do a podcast with him tomorrow, and it'll be up on Tuesday. And I'll send you a snippet, and folks can can chat about that. It's a little bit more kind of down to earth in some sense, and that he's not he's talking about Galileo, one of the first scientists, maybe some say the first scientist in history to use the scientific method, and what became of his life after he came out and declared that the Copernican sun-centered universe was the true nature of reality.
I'd love to hear. That's going to be a good interview, because I got to interview Mario. I worked with him at the Institute, and when Brilliant Blunders came out, I was one of the first hangouts he had done. This was like right before he had done the Stephen Colbert episode. So
right.
So Mario Livio is an awesome guy. We'll talk about him next week. I'd love to read his new book actually as well. So okay, folks. So I'm going to stick around for a little while. We've got about 20 more minutes. I'm going to stick around, chat with you guys for a while about whatever you guys want to talk about, and we'll be back next week. So Bryan, thanks for joining, man.
Thank you, guys. Yeah.
All right.
Really a lot of fun being with you, Tony. Thanks.
Yeah, cool.
Thanks so
Looking
much.
forward to doing more of these. All right.
Okay. Bye-bye.
Bye-bye. Well, you got a brief look at the Drake equation there. I don't know why I have that sitting in here, but I just do. Hey, guys. Okay. Well, what do you guys think of this thing? Is this going to be something you'll watch on Thursdays or not? You guys have some great comments. And I really appreciate your feedback on this. No, it's not over yet, Galaxia, but I am, he's has other things to do on Thursdays, so we're going to make it an hour, but he's going to be on probably for a half an hour, just kind of wet your whistle on what to go look at, and I'll stick around and chat with you guys. Dan, I'm not having a flat earther on my program. There's no point, 0 point in talking to flat earthers other than to give them attention that I'd rather not convey. So I'm not talking to anything. There's nothing you can talk to about it. What are you going to do? They're just going to use it to troll science anyway. So there we go. That's my thought on that. Hey Hans, it's good to see you, and better. Thank you guys very much. Listen, one of the things you guys, if you want to support this, I'm just going to start being blatant about it. You can do the super chats, and they really do help. Last week I got a couple of super chats that really helped this channel. I know I took down the Discord server because I didn't want you to be compelled. Not Discord. Patreon campaign, because I didn't want to compel anybody to support. If you still want to, you can, just by going to deepastronomy.com/donate, or you can just do it here with super chats and all that kind of stuff. It all goes to the same spot, which is, by the way, I should also mention, I am in desperate need of a camera. You may have noticed there's been a lot of noise in cameras here. My main video camera is on the fritz. It's just stopped working. So I need to somehow afford a new camera. So for now, and so any help you can give would go towards that. Okay, so Adam says that he passed the audition. Thanks, Adam. I appreciate it. So hey, Lance Left Hook on Twitter or Twitch. It's good to see you, and Uncle Bill's here as well. And yes, if you do go to the Discord server, Better just posted. I should have a bot that posts this, but I guess it's not doing it right now. So yeah, I appreciate that. I still think dark matter is just normal matter that we've forgotten our calculations. How would we have forgotten it? When Hubble telescope was launched 30 years ago, we still haven't discovered any exoplanets at all. Back then we hadn't, yes. There's a way in which you can measure the mass of the universe without actually having seen all of it. I strongly believe dark matter is somehow connected with negative mass